Welcome back. Okay, maybe some student has a very long lunch. Okay, thank you for coming back. So, like I said, actually I had prepared some practice. So, if we have some chance, it would be better to have some practice, because it's always important to see how the system is working, right? But in this morning, we should have tried to have some practice with my server in Korea. We have some deep learning servers in my office, and if I have, if we have some, like a PC or some internet access, we can test how deep learning architecture is running, and how can we detect the anomalies with a very large data set. But it will be okay, because I will share my video how you can run the deep learning systems on my server. Okay, so I'm going to send my video to the university, and university will share with you guys. Okay, so please, once you receive the link, please check how the system is working. Okay. It's always important, right? So it's always important to have, some chance to run your system. Okay. Anyway, you will learn. You will see how it works. Okay. So instead of the practice, I prepare several slides for next hours. Okay. So in this morning, I was talking about traffic. Right? So I was talking about some traffic, I was talking about some EEG data, and also I was talking about the climate change. Okay? But it will be very interesting if you see how the traffic congestion will be in the near future. Okay? So this is the title. This is one of the paper. And more interesting parts is, this is my PhD, one of my PhD student. He finished his PhD. I don't remember, 2 or 3 years ago. Now he's working in Viettel in Hanoi now. So maybe Viettel also pretty interested in IoT and the traffic control. Okay? So the main idea is computational negotiation. So we have a lot of data from IoT, right? So we want to understand the data from IoT, and also we try to find out what is the best decision. Okay? So this is what we are proposing in this study. So I will introduce several motivation, okay, and also some backgrounds and objectives, and then we are going to see what is the computational negotiation. So negotiation is very simple concept, right? If you go to the market, if you go to supermarket, for example, and there is a price like $100, for example, and you can have some negotiation. Right? You want to have some discount, and the store owner, they want to have more, more profit, right? So there is a negotiation always in our world. But what about IoT devices? Okay? So, for example, in the traffic, some car, we have a lot of car on the street. They want to go earlier right, than the others because I'm busy. Okay? You know what I'm saying? So it's always some kind of negotiation. I'm first, you are first, okay? We have to decide which one is first, right? So this is negotiation. And why we call this is a computational negotiation. This is automatically conducted, right? So all the process, all the negotiation process between the IoT device will be operated automatically, right? So this is the reason why we call this is negotiation, which is like a computationally, right? And also we are going to explain what is Internet of Agent framework, okay? Computational negotiation, and I'm going to show some demo, okay? So we had several simulation and how it works. You can easily understand what I'm explaining now, and some discussion. And not only the traffic, and also we have applied this idea for HEMS. So this is some kind of home management system, home energy management system. I'm not so sure in Vietnam, but in Korea, it's really important to optimize the energy consumption, energy management. If you go to your home, you have a lot of appliances, right? Like a freezer, air conditioner, what else? TV, and you have a lot of electronic devices, and you want to optimize your energy management in your home, right? So this is called the HEMS, and we have applied this idea for energy management for your house. So this is the introduction. Yeah, I put down some figures on the street. So you have the traffic lights. Okay, you have a lot of vehicles. You have a lot of motorbikes. Okay, on the street, and always it's busy, right? You have a lot of traffic. There is always congestions, right? And you want to manage this kind of traffic in optimal way, right? So here, some cities like USA, in Europe, you have a car, you have some kind of train, like which is called tram, and also the people, pedestrians, right, on the street. They want to cross the street, and we have to decide the best decision always, right? Because we want to find the optimal decision. What is the best decision? What is optimal decision in this case? What do you think? What is the best decision in this case? Traffic congestion. When you talk about the traffic congestion, what will be the best decision? What is the goal? What is the goal of this system? What do you think? What do you want with this? Yep. Any other ideas? So we want to minimize something, right? We want to maximize something. We want to minimize something. What? Maximize what? Amount of traffic. Okay. In other way, we want to minimize what? Minimize the congestion. So yeah, you're right. So we want to minimize the total time of the traveling, right? Yep. So we have a lot of vehicles. We want to maximize the traffic. We want to minimize the traveling time of the vehicles, right? This is our goal, right? Understand? So, like I said, in the near future, very near future, all the vehicles will be connected, right? Like thanks to the IoT. You have a smartphone and also vehicles. For example, electronic cars, they have the system to communicate with other vehicles, right? I'm not so sure in Vietnam, but in Korea we also have a lot of autonomous car, right? So they can move without drivers. It's unmanned vehicles, right? So the vehicles can communicate with each other, right? So here we have some communication protocol. For example, V2V, vehicle-to-vehicle communication, or V2X, vehicle-to everything communication. It's already proposed with some standard, right? Standard, and all the vehicle can communicate. They can share their context, their position, their speed, their direction, right? All the information can be shared with other vehicles. This is what I explained in this morning, right? So, see? What do you think? Maybe this is from India, okay? So, some intersection. We have a lot of vehicles, a lot of motorbikes, a lot of people. It's like it's very, very complex. Which one will be first, right? We cannot decide. But what if they can communicate with each other? We don't, okay, we have a vehicle, we have a motorbike, right? But sometimes you decide, okay, I'm the first. You know what I'm saying? On the street. And you increase the speed. Sometimes you decrease the speed, right? You decide. And if you made a very stupid decision, if your decision is wrong, what happened? There's a crash, accident, right? This is bad decision. This is the problem. So you see, it's some kind of complex system, right? Complex problem. You have to decide which one is the first. So here in this study, we try to propose how can we help the IoT devices, IoT sensors or vehicles to decide the orders, the priorities. Okay, so we are proposing a new approach for the decision making for connected objects. Here, the object means any objects. So it could be vehicle, it could be motorbike, it could be anything, right? So here we have to consider this kind of expressions. You see the connected objects, right? So maybe some of you are familiar with IoT, some communication, all right? So there is a lot of communication protocols, okay, to support the electronic devices to communicate with each other. And then, thanks to the 5G, 6G, we have very high-speed communication protocol, and there's no problem to sharing, okay? And edge intelligence or edge analytics. So this is very interesting. You have a smartphone, you have IoT devices, you have the vehicles. They have the intelligence. Okay, they can make their own decision. Okay, most of the system for the moment, for now we have a lot of smartphone, laptop, smart pad, iPad, right? And it looks smart. But they cannot decide. You have to, they ask the users, okay, there is an alarm, there is an information, there is an email, right? You understand what I'm saying? They cannot decide anything. They have no intelligence actually for me. I think this is not intelligent at all, right? They just have a data, they just alarm, they just explain. Okay, please make a decision for me. This is what they are doing, right? Yep. So, yeah. So this is a manual, like you said, this is a manual decision making, right? So in this case, edge analytics, they want to support the edges, like smart devices can make their own decisions. Okay? It's really, how can I say, challenging, right? So Tesla, okay, you have a lot of autonomous vehicles. They can have autopilot system, right? They can identify there is a street, they can move in this way. But the problem is, if there is a lot of cars, what happens? You know what I'm saying? This is kind of like some story for the near future. Okay. Thank you very much. Okay, thank you. So this is called edge analytics. Okay, so they can decide their own decisions, right? They are smart, they are intelligent, they have their own decision-making modules. Okay, and also we have to consider AI techniques. In this morning, so far we talk about the anomaly detections. Okay, for example, right? This is an example. And these devices, IoT devices, the vehicles, they need to use this kind of AI techniques for, for solving this problem. So here you have here there is a internet connection, right? And also there is some kind of gateway to communicate with connected devices, IoT devices, right? So all the analytics on server, this is how current system is working, right? Because they have no, how can I say, intelligence in each edges, right? They collect the data, they send all the data to the cloud, okay? The server decide the decision, right? You know what I'm saying? And then the edges are acting according to the decision from the cloud, from the server, right? But like I said, we want to support the edges can make a decision, okay? So, in this study, we have proposed two issues. The first one is Internet of Agents. So, anyone heard about the multi-agent system? No? Okay. So, if you think like a scheduling problem, you have a scheduler, right, in each smartphone, for example, and you want to make a schedule with other people's, right? They need to communicate with each other. But it takes a lot of time, right? But somehow the agent can help you to make a best schedule, right? So it has been very, can I say, there's a many multi-agent system, MAS, and they, communicate and, for example, the scheduling or some other problems, collaboration problems. But in this case, we said edges, like a smartphone, any devices can be connected and they can collaborate with each other. So we call that's why we call this Internet of Agent. And we want to make it more sustainable because every day, every moment, we have new IoT devices, right? So smartphone, what else? All the electronic devices in your home are connected. Recently, recently in Samsung, for example, they proposed, they released the freezer, refrigerators, and they are connected with the internet, and they communicate with my cell phone, by my smartphone, and they know that, oh, there is no egg, there is no milk, there is no bread, so please buy something new, okay? So everything is connected, so we want to make it more sustainable framework. So that's why we want to call this framework with the IOA, Internet of Agents. So any electronic devices can be connected, and we can put it in the system with the agent concepts, okay? And they can collaborate. They can make a better decision. So this is what we want. And finally, the next one is the computational negotiation. So, like I said, you know, in our society, people negotiate always, right? So we have to consider you have many IoT devices, and sometimes they can collaborate. Sometimes they are competing with each other. Sometimes they, you know, how can I say? They are competing. Sometimes they are cooperating, right? So we can have this kind of negotiation in automatical way. So once you have a connection with other IoT devices, they can communicate. Okay, this is my decision. This is your decision. Okay, somehow we can share the information, and we can find the best optimal decisions. You have the crossroad. You have the car, vehicles, and how can you decide which one is the first? Okay? So you need to negotiate with other IoT devices. So this is emergent research categories. So here, for the IOA, Internet of Agents, for the computational negotiation, maybe you have to be familiar with these techniques. So the first one is knowledge. Okay, this morning we learned that there is a knowledge which is represented as a graph. Okay, knowledge graph. So acquisition. So how to collect the knowledge, something like that, and modeling, and representation, management, discovery, and engineering. So some knowledge, right? And also you have a lot of raw data. Right? So sometimes you have a textual data, sometimes you have a speech data, image data, signal knowledge, and you have to analyze, you have to process the data. And there is a web, okay? So everything is connected, so it's a web. And some classical AI techniques like constraint programming, logic programming, some architecture, and user interface in intelligent way, and multi-agent system, right? Like I said, the architecture, interaction method platform, machine learning, right? And reasoning. So, like a negotiation is really, how can I say, very social processing, right? Like not only the single decision making, but you have to communicate with other people. Sometimes you are cooperating, sometimes you are competing. And how can we reach the best decision, right? We have to use this idea for the IoA, for the connected vehicles, for example, right? So here is the main components for this issue. Why is this not? What happened? Okay. Can you please excuse me? Can you check? So here is the okay. So every day we have a lot of data. So imagine how many data we have. You see the number of vehicles, number of people on the street, right? So it's a vast, a huge amount of data every day, right? So it's really, really important to have the high performance computing, right? And the next one is we have to make it more intelligent way, like I said. I'm going to skip it. From the connected object to smart objects. So far, the electronic devices are just connected, that's it, right? But we want to make it more smart. So not only the sensing means collecting the data, right? Collecting the data, and also we have to consider how to process the data and how to reaction, right? Reaction means once you have the data, you have to do something, you need to take some actions, okay, with the input. And not only the taking of action, but also you have to consider the learning, like a continuous learning. Like this morning we talk about the anomaly detections, and once you learn something new, some new anomalies, and you have to learn it, right, again and again, like a retraining process. So it's also the same. You know, the Tesla is still running, right? They collect the data, and this information sent to the Tesla server, and they are still learning, right? So it's because they want to improve the quality of the service. Okay, so processing the large amount of data in real time and driving real-time actions from the big streaming data. So it must be automated, and also it must be adaptive, right, over time. So if you have some system, the system needs to adapt it in a new environment. Okay. So the research question is, what smart object can do? I already explained about this, right? Distributed management for complex systems. So here, the distributed means that all the vehicles, all the IoT devices, you know, they are distributed, right? They can decide their own decisions. This is what I want to explain. So what kind of technique enables smart objects? So negotiation-based individual decision making. So the vehicles reach to the crossroad, right? And they need to negotiate which one is first, which one is the next, right? And once they decide, once they made the decision, and then they are following the orders on the street. So, and also I already mentioned about edge analytics. So sometimes people call edge intelligence or edge computing, but here we are using this term, this expression, edge analytics. So moving intelligence to the edges, not cloud anymore. You don't need to ask something intelligent on server. The IoT device can make a decision by themselves. Okay, this is the most important part of this study. Okay, so very simple description. Pushing the frontiers of computing application data service away from centralized node to the logical extreme of the network. So it means that all the decisions will be made on the edge. Okay, so the end of the network, okay, the nodes will decide. So it enables analytics and data gathering to acquire the source of the data. So they collect the data. Okay, IoT, the main reason of IoT is collecting the data, sensing, right? But not only the sensing, but also they can make their own decision. This is data. This is edge intelligence. Okay. So negotiation among the autonomous agent. Like I said, multi-agent system. This is very classical problem. Okay, this is not like original ideas. We want to use the idea from multi-agent system for the connected vehicles. Okay, so here is the negotiation. How the agents are making a negotiation. Okay, so here you have the, for example, buyer and seller as a person, right? And they have their own agents. Okay, so buyer has the selling agent. Buyer agent, and the seller has a seller agent. Instead of the person, instead of the people, human, okay, the agent can make a decision for them by negotiation. Here is the bid. You know what is bid? Bidding. What is bidding? It's like proposing a price. Okay, I said, oh, I want to buy this with a $10, $20. This is a bidding, right? So the agent can bid, right? Propose some condition, okay, and then they can make some negotiation. Sorry. Yep. In auction. Yep. So negotiation, okay? Negotiation is autonomous agents interact with each other to reach the agreements, okay? Blah, 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 blah. Just take a look at the description. You can easily understand, right? So negotiation issue is sometimes it will be the resource. So if you consider the connected vehicles, what is the resource? What is the, do you know the critical section? No? Okay. In operating system or in what else? There is a critical sections, and you cannot take the same resource at the same time, right? So for example, if you take the same resource on the street, there is a crash, there is an accident, right? So in this case, the negotiation issue is a resource. And also the capability will be the negotiation issues, okay? Negotiation process. So negotiation issue between the initiators and responders. Okay, so you know you can have some kind of option. Oh, I want to sell this. How much you want to offer? Can you bid? Like a $10, $20, right? So this I'm the initiators. You are the responders. Okay, and negotiation in multi-agent system, a little bit more complex situation. Okay, so you have many different autonomous agents. Okay, and then they can communicate with each other, and then you can find the optimal agreements among the agents. So here is the idea. Okay, interaction from multiple autonomous agents, and then they can use ACL, there is ACL, KQML is a language to communicate with the other agents. So I'm speaking in English, right? So and then we can communicate. But also the agents, AI system, okay, you can say AI. So agent system also have some kind of language to communicate, okay? And they call this is ACL. Agent Communication Language, also KQML. I'm not so sure. Knowledge, Korean Manipulation Language, something like that. Okay, so you can Google. Okay, this is also very well-known languages for agents. Okay, negotiation approach of autonomous agent. So we can see here some category for the negotiation. Sometimes the agents are, collaborating with each other, right? Okay, so here is the collaborating on the right hand side, okay? And sometimes they are competing. They want to win. They want to take the resource earlier than the others, okay? So this is competing. And in the middle, compromising. They want to have some compromising. You know what compromising means? And sometimes they want to avoid. They don't want to have a negotiation. I just want to play with you. Okay, I want to leave. This is avoiding. Okay, and also accommodating, because I won't have collaborate with other agents, but I want to accommodate. Okay, so this is a very well-known category for the negotiation. Okay, so what about the scheduling? You have in your company, in your university, you have many friends to have a schedule. What do you think? You need to collaborate with other people, right? Okay, Wednesday is okay, but Friday I'm not okay, and you need to communicate, you need to negotiate with other people to find a solution. This is collaboration, right? But competing, it's an option, something like option. Okay, you need to compete. I want to win. So nowadays in China, you have Asian game, right? Asian sports game, and they are competing with each other, right? I want to win. I want to take the gold medal. So it's competing. Okay, so there are many types of negotiation. But what about outside? Outside on the street, you have a lot of cars, a lot of vehicles. Do you think they are competing or they are collaborating? Which one is better? What is your opinion? Competing? They are competing, collaborating. Some other people, what do you think? On the street, there are a lot of motorbikes. They are competing or they are collaborating? Collaborating? Competing? Compromise, okay. Some other ideas? So what do you think? Which idea is good? They are competing is good or collaborating is good? Collaborating is good. Okay. He said collaboration is good. What do you think? What, do you have any other ideas? No? Okay. What do you think? On the street, you can see the signal, traffic signal, green light, green and what is it? Red, right? Green and red. What do you think? You can see the signal, and what is the role of the signal for the negotiation? What do you think? Meeting, okay, and some other ideas. Okay, I will explain later, but they can control the negotiation, because if there's no signals, you will have a lot of negotiation at the same time, right? It's not possible to find the best decision. So there is a signal to minimize the number of negotiation. Maybe I will explain my conclusion first now. If all the vehicles are connected with each other and they have the negotiation automatically, what will happen on the street? There will be no signals. What do you think? What do you think? Do you think so? Agree? Disagree? If all the vehicles are connected and all the vehicles are negotiate automatically, they can decide which one is first, which one is next, and then there will be no signal on the street. What do you think? In the near future, not now, but okay. Some other ideas? Sorry? Pedestrians, the people, okay. Some other ideas? What about the people? People has a smartphone, right? Somehow we can communicate with vehicles. So, okay. Some other ideas? No? Okay. Maybe if you look at if you take a look at some science fiction movies, you know, sometimes there's no signal, so I'm free to go, and all the vehicles are automatically recognize I'm on the street and so on. So because the people is most important thing, right? People is more important than vehicles. So if I go to the street, the vehicle must stop, right? So, anyway, there is a lot of, you know, various scenarios, stories for the futures. Okay, so maybe this is one of the idea for the future, right? So all the vehicles, all the pedestrians are connected, and we know that, you know, what is the best decision. Okay, this is pretty interesting and very important parts of my talk. So for the negotiation, we want to make it automated. Okay, so we have to specify the key data structure of the negotiating objects and the process operating on these structures. So have you heard about the game theory? Game theory? Game theory. You play with the, you know, you play with the other people, other objects, other systems. You need to consider the game theory. What is game theory? Do you know any algorithm on game theory? You have a lot of data, right? And then you have to decide some decisions. What is the game theory? Okay, I want to sell this microphone to you. Okay, and I want to sell this $100, and you said, oh, $50. I want to buy it with $50, and I said, oh, no, I want to sell it from 100 to 90. Okay, 90, and you said, oh, 60. Oh, I said, oh, 80. And you said 70. And finally we will reach in the middle, right? Yeah, 75 or 80. Yeah. So this is some kind of game theory. It's some kind of finding the equilibrium. Equilibrium, you know? Nash equilibrium. Find out what is the optimal state. What is the optimal state means in game theory. We want to maximize your happiness and my happiness, right? You are agree with $75, I'm happy with the $75, okay? We want to maximize the total happiness of the players, okay? So this is how the game theory is working, okay? This is very simple ideas. And there's another ideas for the negotiation, of course. People, you know, have a lot of different ideas, interesting ideas, and there is many heuristics, right? Meta heuristics, and also there is some kind of augmentation-based approaches for negotiation. Because we have a lot of different situations, you want to augment, you know, your data, your situation, your conditions. So we want to put the we want to put the game theoretical negotiation in these connected vehicles, and also we want to make it automatical way, right? So this is the system we have designed. Okay, so there is an agent architecture. It looks very small, right? But okay, there is an agent architecture, and also there is some kind of communication facilitators. Okay, like you know, there is a radar, there is a antenna, there is you know, a lot of you know, IoT devices to communicate with other devices, right? So we put together. And then we call this is IoT-based intelligent agent, because this agent can communicate with the other IoT devices. So this is a simple definition of the system, okay? So IoT-based intelligent agents can be represented IPKE. So I is the identification of agents, which is some kind of ID, accounts of the agents. Okay? And the P is the communication protocol. Okay? Like if you consider the HTTP, the number of ports is 80, right? And also you have some other communication protocol, and you will design the number of ports, okay, to the communication. And K is knowledge you have for the agents, okay? And E is specified behaviors, okay? So like a negotiation and what kind of negotiation you have, something like this. And then here the specified behaviors will be represented as MAU, okay? So here is the possible activities for A, and the message for M, and U is the utility function, okay? Like I said, happiness is some kind of utility function for agents. Message type, maybe this is like a communication part. So when you send the message to another agents or some other systems, you have to decide the rules. You have to decide some grammar, right? So in this case, we design the format for the message, okay? So I'm going to skip. This is not actually the main part of the study. So this is some kind of format for the message. I'm going to skip it. So here is the request, reply, release. So they are using this kind of message to communicate with the other IoT devices, other agents. Okay? So this is also very important in this work. Consensual negotiation. When you negotiate with other people or other agents, you can reach some decision, right? But if you have many IoT devices, many agents, what happens? Okay, you have a negotiation with the players. Okay, I have a decision, I have a decision, I have another decision, I have another decision, right? So you need to find out what is the consensual. Okay. Maybe this is more social study, right? So anyway, you have the in here on the left side. It's a centralized approach. You have a server, you have a cloud, and once you have negotiation, you need to put it in the server, and server will decide what is the final decision. But in this case, right side. This is fully distributed approach. So all the IoT devices will decide the decision, right? By communication with other agents. Okay, this is how we have the negotiation by exchanging the message between the agents. Okay, we also consider the competitive negotiation. They don't want to collaborate. Okay, I want to win always. Okay, this is competitive negotiation, and this is how the system is defined. Okay, like I said, in this case, we need to consider the Nash equilibrium. This is, one of the famous mathematicians, right, in history, human history, Nash. He proposed an idea how to reach the equilibrium between the players. Okay, so this is the equation for Nash equilibrium. Okay, so we are using exactly the same idea for the IoT devices. Okay, connected vehicles. Okay. There is another negotiation process. So I don't know how to pronounce. This is a French guy, Kuno, I don't know, competition. He also proposed the idea of how to negotiate. Okay, so this is how it works. And also, I'm not so sure my pronunciation correct. Stackelberg, I'm not so sure. Okay, Stackelberg competition, also another negotiation process. Okay, there are so many different negotiation processes. Okay, anyway, we try to apply, many different kinds of negotiation process for the connected vehicles. Okay, this is another, okay. We need to put the game theories, theoretical negotiation in the competitive negotiation process. But now if the IoT devices collaborate with each other, so that's why we have to consider cooperative negotiations. Another case, another scenario, okay? So here in this case, we are using the merge and split algorithm to have the cooperative negotiations. Okay, so use case. So I'm going to show you the results from the simulations. Here, if you consider the traffic in the real world, real case, we can use the traffic lights, and mostly the traffic light is working in the round robin scheduling. You know, so in this direction 30 seconds, this direction 30 seconds, 30 seconds, 30 seconds, right? Everything is controlled by the fixed duration of the lights. Okay, so this is round robin, and the problem is lack of the real-time scheduling, right? What if there is no vehicle in this direction? But anyway, we have to wait until the lights change, right? And we also want to consider the waiting time of the vehicles. If it's very busy in this direction, we need to expand the duration of time, right? You know what I'm saying? So it depends on the number of vehicles in a certain direction. You need to change the duration of the lights. Okay, so this is what I was thinking, and I already talked about the message passing for the system, right? Like this. Okay, this is communication protocol. I'm going to skip. Okay, so this is the simulation from Net logo. You know the Net logo? Have you? Okay, so Net logo, Sumo, they have the traffic simulators. Okay, so this figure is from Net logo for the simulation. Okay, so we can use this to simulate how our negotiation process is working in a different situation. Okay? So here is the example. How can we reach the equilibrium? Right? So there is some equation. I'm going to skip it, okay? It's not so important. You just understand what I'm explaining, the main concept. Okay, so we consider only 4 directions. Okay, just one intersection, right? But in general, we have many different intersections, right? So we have 4 different intersections in our area, and how can we decide the agreements between the connected vehicles? And this case and also this case, the negotiation is always important. And also we need to play with the other connected vehicles to make a decision, right? Okay, another simulations, like when they are competing with each other, when they are collaborating with each other, right? Different cases. So I'm going to skip it. Skip. Okay, experiment. Maybe this is most interesting parts. So like I said, we are using that logo as a simulators. Maybe you can Google, you can download it, you can easily use it. So this is based on the Java. You can use Java languages to have the simulations. And okay, so here we simulate with the three different scenarios. Okay, so isolated intersection with the traffic lights, isolated intersection without traffic light. I already mentioned that in the near future we will have no traffic lights. Okay, So in this case, how can they play on the street? Okay? And last one is multiple intersection. Like I said, there's a 4, not only one, but also 4 different intersections with the traffic lights. So we consider 3 different scenarios with different negotiation methods. You see, we have the better results, always better results. So the last one, green one. Green one is our result. And the round robin is a blue. On the street, the light, traffic light is in a round robin. Am I right? Yeah. So we always have a better results with a different density of vehicles. Okay? Okay, I'm going to skip more details. So in this case, this is average waiting time. You have the vehicles that we try to simulate what is average waiting time of the vehicles on the street, on the intersections. And also this is a number of vehicles passing in a certain time. So he said the goal is to maximize the number of vehicles within the same time, right? 1 minute, 10 minutes, 1 hour, something like that, right? So here, almost the same results with the uniform traffic volume, but non-uniform traffic volume. So we have put some random parameters. We change the number of traffics over time, and in this case, we have the best results, right? The green one. We accommodate the large number of vehicles, right? More than round robin. And in case of cooperative negotiation, also we have best results in terms of average waiting time, and also the number of vehicles passing on a certain time, right? Consensual negotiation, also we have very nice results with this, okay? And so on. So, okay, the one is almost finished. Can you play the number? It's not here, sorry. Sorry, he's not here. I don't know how to play the demo, but I prepared some video for the demo, but anyway, it's okay. We have this kind of simulators, and then all of the scenario, right? Multiple intersections, single intersections with different negotiation methods in terms of waiting time, in terms of number of vehicles, we have always best results. What if we have a really large number of vehicles? For example, in rush hour, when you come back to your home from the office, like 8 p.m. Sorry, not what is rush hour in Vietnam? 7 p.m., 8 p.m., 5 p.m. Okay, 5 p.m. You have a lot of vehicles. What happened? What do you think? The negotiation is working or not? Probably not. Definitely not. Yeah. Anyway, there is a lot of vehicles, right? And this idea is not working, right? Of course. And what if very early in the morning, very late at night, what happened? There is only a few cars. What happened? Do you think this idea is okay? No. There's only a few cars, right? No negotiation, right? You can free to go, right? You know what I'm saying? So if there is only few cars, or if you have a lot of cars, this idea is not working. Okay? So we are considering that just we want to optimize some state in the middle, right? You know what I'm saying? Okay. So this is what I was explaining. And conclusion. So we are presenting the Internet of Agent framework, okay, for the connected vehicles, for IoT devices in the future. And we have to consider this kind of study. You know, our future is very near, right? So we need to prepare. And we propose a new approach for edge computing, edge intelligence in IoT devices, IoT environments. Okay, proposing a computational negotiation model for different scenario like this. Okay, we put some scenario. We had some simulation, and we had a better result than the others. Okay. Okay, this is expectation. So we expect that computational negotiation among the connected vehicles play an important role on the near future with a lot of IoT devices. And there is some related work, related issues. Please take a look at. And finally, we expect that the proposed techniques can be applied for other smart scenario in connected vehicles. You know the ITS. We in Korea we have a lot of high speed like a highway, and then we can use some IT and AI and also big data techniques to manage the traffic in the yep. Okay. Okay. I hope Vietnam also have the ITS, the Intelligent Transportation Systems, and it's really important because everything is changing so quickly, right? So we need to prevent. How can I say? We need to prepare this kind of new changes with the AI techniques. And the next one is the swarm intelligence. Do you know what is this? Ants, right? So like I said, the vehicles can communicate with each other, right? By using some communication protocol. And ants, they can communicate with each other. How? How they can communicate? Do you know how they communicate? Pheromone, yeah, pheromone. They have a pheromone. They know where is the food for the ants, right? And then they can find out the way, the routes for the foods, and then they can share the information, okay, by using the pheromone. And then somehow they can find what is the optimal stage, optimal path, something like this, okay? So it's very similar with the connected vehicles, right? So the vehicles are communicating with each other. Where is the accident? Where is the traffic? Where is the, such information, right? So this is very similar. So somehow we want to apply the swarm intelligence for the traffic, okay? The last one, last slide. Once we apply the IoT and computational negotiation and so on, we had a very nice results, and we planned to apply this idea for home energy management system, HEMS. So if you go back to your home, there is a lot of electronic devices, right? Like a TV, oven, laundry machine, what else? Your computer, electronic car. Do you have electronic car in Vietnam? Yes? No? Limited. How to recharge? you have some devices to recharge your car? No? Okay. In the supermarket, there is a station for recharge. Okay. Like I said, environment is always important, right? So people think about the energy, okay? So like a gasoline car, diesel car, they are, making a lot of carbon, right? So we want to minimize it, we want to remove it. So that's why people are using the electronic car. So anyway, when you come back to your home, there is a lot of electronic devices, right? But the problem is you want to optimize it. You want to manage your energy. Otherwise, you need to pay a lot of money, right? So, for example, if you have some renewable energy devices like a solar panel or some wind turbine in your house, and then you can generate a very small amount of energy, right? So you can use the time. Okay, this is the result. You can use a time-dependent energy consumption. Okay, for example, solar panel is working, generating the energy during the daytime, right? Am I right? So you can consider what time will be the best for your TV or for your electronic car. You know what I'm saying? Makes sense? You understand? So it's better to use your recharge at night. For example, this is an example, okay? So you have to decide the time when you have to use certain devices. You have a TV, you have a computer, you have a cell phone, you have an electronic car. They have a different types of consumption, right? Consumption. And also you have some renewable energy generation. So you also need to consider all different situations, and then you need to decide, okay? So this is how it works. So here, so this is the time in second. Over time, you have a different consumption, different generation, okay? So if you have some AI system, like a Internet of Agent system, the automatically decide, okay, you have to use recharge from now during 2 hours. Okay? This is how it works for smart home energy management system. Okay? So far, the people are applying some rules. Just very simple rule. Okay? From 2 p.m. until 4 p.m. I want to recharge. This is the rule, right? But without any rules, the AI system automatically decides the time and the patterns and so on. Okay, this is what I was explaining for computational negotiation with the IoT devices. Okay? Okay, I want to finish it now. Here is several articles for my reference. So his name is Quai Nam Bui. He's working in Viettel now. So he's one of my PhD students. It was really interesting with many different ideas with IoT. Okay, thank you very much. Any question? No? Okay. So like I said, just when I begin talk, I will share my slide with the university, and also I will put my video. If you want to have some practice, okay, you can access my server, and then you can play with the anomaly detection and deep learning architectures. And, okay. Hopefully you will have some insights and good experience. Okay, thank you very much for the lectures during two days, and I hope you have a good experience. Cảm ơn.